Okay, good morning, or it's probably afternoon now. Not sure where I am, on the West Coast. Time's all confused, but I'm going to talk to you about a project that we're working on for doing wiring of electrical cabinets, and it's a publicly funded project, so I can actually talk about it, and so it's a good deal. Yeah, I'm not even going to go into all that. So let me give you just a couple of minutes of background on electric boat and shipbuilding in general. This should be the shipbuilding track, right? Not oil and gas. But so Electric Boat is a 115-year-old company. It was founded at the turn of the previous century in 1899. This eccentric inventor, John Holland, created the first modern submarine on speculation, had this crazy idea, and managed to sell it to the Navy. And that company changed names. At one point, it bought a facility in Groton, Connecticut that had Electric Boat in the name, so it became called Electric Boat, but not related to the submarine per se. And then Electric Boat went on to build the first nuclear sub, the first nuclear ballistic subs, and the Nautilus in the 50s, and then the ballistic subs, late 50s, 60s, and it was the founding division of General Dynamics, a large defense contractor. Focused market, that's a nice way of saying we have one product and one customer, right? So most people can't get away with that in the business world, but it works for us. Okay, submarines. And shipbuilding in general is a large, complex platform, long design cycles, 10 years for design, roughly 5 years of construction, start to finish on each product. It's sort of the quintessential high mix, low volume, right? So we currently are building 2 submarines a year, but that's new. For the last 10 years, we've really been only building 1 submarine a year. And it is an odd mix of high-tech and low-tech, so there's heavy steel manufacturing, is kind of like heavy equipment manufacturing, welding, but then there's a certain amount of precision work, and there's a lot of outfitting, much like building construction, AEC kinds of things. So it's an unusual environment to work in. And so Electric Boat's been involved with VR for a long time. Back in the early 90s, we actually, in 91, 92, we started doing work with electronic mock-up and large-scale visualization. So there's an aircraft manufacturer in the Pacific Northwest that got a lot of press in the 90s for their digital pre-assembly, and we were basically concurrent with them doing the same things, but all of our pictures were classified, so no one, if you're not in the Navy or Congress, you didn't see any of those. But we do VR design review now. That's standard and standard across shipbuilding actually now. And we were a pioneer in that a long time ago. And that's standard practice now. And we're currently working on new VR stuff, so low-cost VR headsets. That's kind of the popular thing these days. And we're getting involved with some AR applications as well. Okay, so what are we doing? Here's the problem is we actually wire a lot of electrical cabinets. So here's an example of the laser pointer not working. Okay. Some shipbuilders buy cabinets pre-wired. We actually wire most of our own, and this is what it looks like when it's done. And this is your work instruction, typically. It's just a table. You get a wire table. It's got the point-to-point connections, got a signal name. It's got a wire color, which could be anything, but it's always white. And your task is to build this pretty result when it's all done. And after you had 4 or 5 of these in place, it'd be easy to finish a row, but the first wire you put in, you have to figure out how long to make it in order to do all this extra shaping and how to bundle them together into cable bundles, and there's a certain complexity there. And for the worker, if you only build 1 of these a year, or maybe you build, depending on the cabinet, you might build 1 a month or something like that. But it's still something that you don't do. You're not doing the same work every day, and so there's certain amount of time spent staring, right? So I'm an engineer. When I'm facing some problem, either at work or at home, I tend to kind of stare. And I'm thinking, but I'm not actually getting anything done. And so there's a certain amount of time spent deliberating. How am I going to put these in? And we're trying to eliminate that. Okay, so the solution to that, it's bigger than AR, right? So part of the solution to this is to build a 3D wire model. And we're using Siemens NX now for our CAD platform. And there's a wiring package built into NX where you could actually model the 3D routing of wires and wires bundled together into cables. And you can create that in your product model up front. We have a full 3D product model of the submarine structure. But this is new. Now we're going to add wiring into that 3D model. And this was something that was done by our electrical group ahead of any work that we're doing on the AR side. So they've gone through this evolution. So you start with a wiring table, and they did some things with schematic representations that had a little bit of pictorial information. They considered using form boards, doing a wire harness, off-hull wire harness, and in their evaluation, they decided that that was not the best way for them to do it. And so they decided on doing this 3D wire model as part of the product model up front. So that work will already have been done to have data for us to use. Okay, so what we're going to do is we're going to take that 3D model, and you can go ahead and play this. Click to. So we're going to take that 3D wire model, and we're going to overlay it onto the cabinet, and we'll show connectors, we'll show wires, we could show individual wires and where they connect, and provide guidance to the electrician, the installer, of how to route that cable in an open space to get the right result when it's done. And we think this is going to be beneficial. So this is screen scraped off a tablet. Again, we're using a tablet, and we think this is going to be a helpful tool for the installer when they go to do their work. All right, so part of the basis of this is an application. This is actually developed on the PC. There's a 3D viewer and there's a wire table. But the significance of this is that we have 3D product model now for the wires and all of the connectivity and bundling. We've developed a push-button operation to extract that data from the product model and put it into a visualization tool. So this is really, it's a 2-button process. There's the user goes into NX, calls up the model, or Team Center calls up the model that they're interested in viewing. They push the button, it extracts all of the geometry and connectivity, product structure information, dumps that to a local file in the file system, and then they push another button, and it takes that data and it builds the visual representation, OpenGL, and builds all the table information. And the only way that the AR application will be cost effective is to have this push-button connectivity. If you have to go in and build your data for every time you want to use it, every application, it's not going to save you any money. You're going to spend more time mushing your data around to get it to draw your pretty picture. It'll look great, and everyone will want it, but it's going to cost more to do than what you're going to save in the end. The other part of this that's interesting is the viewer here. This is it's written with something called Joggle, JogAmp, and JavaFX, and so it's written in Java, but it draws directly to OpenGL, and we've shown that we can take that same graphic and have it draw on the tablet, which is running Android, and so we can do development on the PC and then suck all of that graphical OpenGL code onto the tablet and have it run with a simple wrapper around it to make it work. Okay, so in the big picture, this is an NSRP-funded project. That's a National Shipbuilding Research Program. It's similar to the electrical power group. It's a collaboration of the major naval shipbuilders in the U.S. It's funded by the Navy, but it's a collaboration of private companies, and they do collaborative research to save money. Our project it's 18-month project, 2 phases. We're going to wrap up at the third quarter of this year. The cost savings goal, so we projected a savings of 30 seconds per connector. So that's pretty minimal, but at 750,000 connectors, that ends up being a significant amount of time in the big picture. And obviously there's other applications, but in this case, we think that we'll be able to save money in this particular application, and it's a first start for us in terms of a production rollout. All right, hardware platform. So we as well are using a tablet. We're using the Google Tango tablet. If you're familiar with that, it's a 7-inch Android tablet, pretty powerful CPU, GPU. It's got built-in motion tracking, and it's pretty easy to use on the software side, programming against it. And the AR, it's video overlay, so we're drawing on top of live video. This is probably not the ideal device for this particular application, but it's a device that works. Glasses would probably be better, a hands-free kind of operation, but I tell people usually my experience with glasses so far is it's a one-hand-free operation, because I'm always holding the glasses to find that exit pupil for both eyes so I can actually see the thing that I'm trying to look at. And so I get one hand free to do the work that I'm trying to do. So the tablet's not ideal, but we could put it on some kind of a stand, and we think that seeing the correct locations inside of the actual workspace will have enough sort of gray matter retention that there'll be a cost savings in terms of time savings when it comes to actual installation. And the software would run on other devices, so when there's good glasses or helmets that work and are cost-effective, affordable for us, then we'll use those. But for right now, the tablet works fine for what we're trying to do. Software development, so this is it's in-house developed code using a variety of open source libraries. We're not using any commercial AR tools, although the Tango comes with a lot of sample code that essentially serves as an SDK for much of the work that needs to be done. But we've used OpenCV for a long time for image processing, and we're using markers right now, and it's an OpenCV-based marker tracker, so that was easy for us to incorporate. We don't necessarily need to own the code or to do our own thing code-wise, but it's been helpful for us to understand the technology better by doing the code ourselves. Right? So we know exactly what's going on under the hood, and downstream we might use other products for that, but it's been helpful as a way to get started. And also, there's a lot of churn in it's a relatively immature market for AR software, and so you have to be careful what you decide to latch on to, because it might not be commercially available the next year. So I don't know. Not everyone can afford to do work themselves for application development, but so far it's been useful for us. Okay, so data access, I think this is probably the most important thing. We think there'll be cost savings from the particular application of wiring and having AR, but the cost savings really is based on having good data. So we have a we have a rich product model for the submarine, and we'll have 3D product model for the wire, which if, as I said, if we had to go in and build all of that for this application, probably wouldn't save any money in the end. Direct access to the data, so again, push button access, that we've seen this with on the VR side when we do design review, that if there's so much data that we have to deal with on the design review side that if it wasn't automated, it would be overwhelming, right? So you've got a million parts that get transferred every night, and if you had to go in and touch each of those to change their colors or assign names or something, you wouldn't be able to do it. You wouldn't be able to keep up. So data access, a big deal, and configuration management. Again, these are all for electrical cabinets, probably not the most critical item on the submarine, but everything we do is there are all these non-deviation drawings. Everything has to be done correctly and inspected to be correct, and there's the management of the data is I guess in any big construction enterprise where you're building things that change over time, that you need to have good configuration management. That's a typical issue. So we're interested in AR for manufacturing. There's other applications. This is a pretty small application, very focused, and it's AR on a small area, small scale, small area. There's obviously other things that can be done on the manufacturing side. There was a question asked about metrology earlier in the earlier session, and we see anything with we did a big study on our current construction work, and there was a large percentage of the overall construction hours that were identified as locating, so generally locating activities. And there's some of the measurement has to be very precise, and AR is probably not going to be good enough to do that, but there's a lot of places where you're just generally identifying where things are, or with cable hangers, we do a lot of big cable installation in cable trays in the overhead, and you're not measuring per se to get a precise measurement. You're just trying to see a path, a route through existing structure, and so generally locating where things go, and we see a lot of potential applications for that for AR. And anything where you're projecting onto the work surface. So we have been doing work with laser projection for years. That I guess we don't really think of that as AR, but I guess we could take credit for that as being AR. So we've been doing laser layout for certain things. Submarine as an airframe, it's a complex thing to measure to, because you have along the length of the submarine, you have frame lines which are pretty clearly laid out, but otherwise you've got vertical and horizontal or thwartships dimensions that are referenced to this 4-foot imaginary grid system, which doesn't exist, right? So you have this plane and space here that you're trying to measure to, and there's nothing to put your tape measure against, and so everything's complicated. So if you can lay out work and locations without having to measure with a tape measure, or if you can hold up your magic tablet and show locations in space that exist in 3D space that you can walk around, there's a lot of time to be saved. And then work construction delivery, it's been mentioned before, so there's lots of opportunity for that. So other things, we focused on manufacturing first, so we're working on a new submarine program, and so there's a lot of activity going on with on the manufacturing side, trying to save money on manufacturing, but obviously there's, for shipboard operations, for the Navy itself, we just build the platform, and then we sell it to the Navy, and we don't operate it, they operate it, so they own it. And, but obviously there's money to be saved there as well for how they manage the day-to-day operations of the submarine, what's underway. Orientation, wayfinding, right? So AR has applications in that area for knowing your way around, finding if something needs to be inspected and you need to find out where it is, you can do your Google Maps thing live, walking around inside. That would be useful. Part identification and obviously maintenance and repair. And we'll get to those things eventually. We're focusing on the thing that we're doing right now, which is the construction. So that's what we're going to work on first. And I think that's, yep, that's it. So, and again, this is public. It's publicly funded through NSRP. So there's information that will be available once the project's done, and you can go to nsrp.org to get updates on the project when it's done. And we're hoping to release the software as well as open source. Most of the software was open source to begin with, so we're going to release whatever we do when it's all done, so later this year. All right, thank you.